Welcome, I'm Bill Wake. This is my summary of the work we've been doing on Twitch lately. We're working on a game called Betwist. It's a word finding game, and the thing that makes it different is you can twist the board and move the letters kind of around the circle from it. This week, we worked on improving the view, so we added those pastel colored cells, and among other things. We added the notion of prefix credit, so if you guess a word and it's correct, we give you credit for any prefixes it has. So if you guessed bookkeeping, then book is counted for you. All right, then we added the notion of finding all the words for a board, and we haven't quite worked out how to show this or what to do with it, but it seemed significant enough to be worth a few days' work. And one of the things involved in that was some performance improvements. The first time we ran it, it worked. It found all the words in a board, but it took about 2.5 hours. And we did some straightforward performance stuff and got it down to 1.5 seconds or so, maybe a second. That's fast enough. I'm able to use it, but I'm not willing to use it to be like before you're working on your board, you have to wait 1.5 seconds. Feels just a little long. If that were 1/10 of a second, I wouldn't give it another thought, but I'm not quite sure where to go with that, but we've got it. Certainly we can do it if you've solved the puzzle to your best ability and you want to know what other words there are. A second at that point, a little spinner or something maybe, wouldn't feel too onerous, I don't think. So we'll see. I haven't quite decided. All right, so let's do a demo and a code walkthrough. All right, so I've made this, ran it, got this board. I've guessed a few words. I didn't know Hain was a word. Okay, but there are certainly others in here. How? I don't have any R's. I'll just live with Howl. We've made these cells. They were black and white before. Now they've got some, each cell's a different color. It's kind of uncoordinated. It's random anyway, per cell. At one point we did something that was kind of like pink to purple, east to west or something, it was very visible that they were correlated. Okay, and I'm trying to think if there's any other things. Well, we did some minor things. At one point you had to click on the letter, and now you can click pretty much anywhere in the cell. I haven't really felt like we're quite done with this central board yet, so I don't want to spend too much time, fighting those sorts of things. But that one was worth it. Just, from all my demos, how many times I click not exactly on the letter and had to click twice, and also this thing of getting the partial answers or prefix credits. All right, now let me modify it to put back the list of all answers. Okay, so we just list them down there. There's a lot. Okay, they have to be at least 4 letters. But I don't know, that seems like maybe 150 or something. And notice it's redrawing that list each time, and it's not unbearable. Okay, but on the other hand, it's not, there's just a little unnatural pause. And so I'm not quite sure what to do. One of my viewers had the insight that if you had this list of all the words, you wouldn't need it when you're scoring the board, because you'd know every possible word if they typed one. OATH, we could just search this list of a couple hundred words rather than searching 250,000 words. And that's a good performance thing, but I have to say that without doing this calculation every time, just looking up a word one at a time, even when we had a relatively slow way to look up words, it was fast enough for the interaction of that. So I'm not sure we'll use that or not. It depends. I may make more complicated boards, bigger boards, things like that have more opportunity. And in that case, maybe it's more worth it. So I don't know. We'll see. Now let's look at some code. All right, so the The first one was that notion of when you guess a word, which is collect is what it's called when you're doing that. We go through and we just run through all the prefixes of your word. Minimum size is 4 up to the length of your word, and we put them in the little summary list on the bottom that has the words you guessed. Very straightforward. The fact that we had to call the dictionary, 10 times instead of once, it's tolerable. All right, and then the second one is this notion of all answers. So finding all those answers, and I think there's some refactoring to do here, but this is sort of the core recursive routine to generate every possible word in the board and capture the ones that are valid. Okay, and so we have our grid, row, and column indexes. We look at the location for each one, and we simulate if you took an empty selection and then you started from this letter on the grid, we'd like to try and get all the stuff we can. So we have this notion of contains and prefixes. So this is the real place we had to do our performance work, but this routine doesn't change from that, really. So vocabulary now has a method that says, do you contain this word? And are there longer words that start with this as a prefix? Combining them like that, we originally had them separate. Computing them together is just easier we're using a binary search. And so the search tells us either here's where the word is or here's where it would be if it existed. And that's exactly the place where, the word after it would be a prefix. And, or if it starts with the same letters, then it would be a possible future word. Okay, so we get back these two states, and they're combined because I think it's like sine and cosine. They have very similar computations to get them. And if you ask for them separately, it costs 2x, but getting them together might cost 1.5x compared to sine or cosine. And so it's the same for us, because that answer we get is where is it or where would it be? It has these two things. Calculating the two together is very similar. So, well, it's much less expensive than calculating them separately. And our routine first would check, is it contained in the dictionary? In case it is, add it to the selection. Or if it's prefixed, keep going. Okay, if it's not prefixed, in other words, if the word you entered has no longer words behind it, then there's no sense in searching for more. So it's kind of driven from the dictionary. Otherwise, we try a whole bunch of words that are just jumbles of letters that can't go together. All right, now the refactoring part is try all extensions. You'll notice in a moment here, it's very similar to this piece of this routine. Okay, we have to get some neighbors, but then we get a selection, and then we look contained or prefixed and go from there. So my hope is that we can treat generating the first location, I think we could give grid or game, or I don't know, we'll see. Game or somebody should be able to say, what are all the cells? Okay, and given an empty selection, what's a valid next choice? Well, it's really all the cells. So I think if we did that, these two would be so similar that they could fold together completely. But we tried it first on Friday or Thursday, and didn't quite succeed. So we'll try again. Now, the vocabulary is kind of where all the real work was. Before, we just did a linear search. We loaded up 250,000 words and did a linear search on them. And then if you're just searching for one word in there, it's fast enough. If you're searching for 155,000, which is what we counted one time that we were generating, you need something faster. So let's see what we're doing here. And so contains and has prefix. Now they both call this common routine contains and prefixes. And what it's doing first is find the index, use a binary search to see if this target string is in our dictionary. if the index is outside the range of the words, that means the prefix we were looking for is like z. There's no chance that it's not a word and there's no words after it, so we return false for both values. And then if we match it, then we did find it. Okay, well, if the next word is after the end of the dictionary, if it was the last word, in other words, then there are no more words to look for, so it gets a false. And otherwise, it's contained because we just found it. But if the next word starts with the target, then it's going to be longer because we just found the shorter word. And that means there's more you could do to search for it. So what we get back from starts with determines whether it's a true or a false here. Now, if we don't find the word, we have a case where we have the prefix that we've got is not a word, but it could be that extending it creates a word. So if I've got C-A-T-T-L-E, if I got C-A-T-T, I don't think that's a word by itself. And so it would be false for contains, but it is a prefix because cattle and I don't know what else, other things are in there, as long as there's at least one. If the next word, we didn't find it, so the word we're at, if that one starts with a target, then yes, there is a prefix word, one or more prefix words. All right, and then the binary search, I took it from programming pearls and munched it a bit, mostly to get it into Swift. But it basically runs a lower bound and an upper bound, and you keep working your way from the midpoint and decide if, is everything left of me smaller than me, okay? And if so, we move one side, and if not, we move the other side, and we keep narrowing in until we can return this last value upper, and that tells us if it's here, where is it? If it's not here, where would it have been? And that, again, is what we need to get contains and has prefix. And we did not try and drive the algorithm out with TDD. We just TDD'd the result and did some plausibility checking, to make sure that it was finding things and putting them in the right place. Okay, so coming up this week, we want to do that refactoring around finding all words and see if we can make them into one routine or one main routine and a helper with less duplication. I have the notion of showing potential neighbors. So when you click words, let's see. All right, so the last word clicked, the first word clicked has a slightly light gray background. The last word click has a red, and I'd like to do something. Either I'm thinking maybe put a kind of a pink border around the neighbors, or maybe a very light red overlay or something, but it would highlight SKYU and then wrapping around Y, G, or Q. And I think one thing this will do is it'll make you understand more easily that you can wrap around the board. It'll give you a visual indication. Otherwise, you could play the whole game without realizing that it's very similar to the commercial boggle and not know that you have this twisting notion. And we have the ability to drag the board and get that. I want to change the way that looks. I want it to look more like scrolling on an infinite canvas. But at any rate, you do have that capability to move the board around, and that is the twist. I think by the end of next week, we'll look at that new scrolling model and see if we can give it a different feel. And I think what'll happen is you'll see more of the edge around you, but it'll duplicate as if it were kind of stamped multiple times. All right. But I don't know. Well, we may, my record of saying here's what's coming up and then actually what we do is not 100%. So I don't know. There may be other things that seem more important than that, but that is one of the things I think will make it much more clear that there's this notion of wrapping around the board or wrapping around the grid. If you'd like to join us, it's Monday through Thursday, 2 to 4:30 Eastern Daylight Time, at least while that lasts, 6 to 8:30 p.m. UTC. You can go to xp123.com/Twitch during the live sessions. I think Twitch has its own saved sessions there, kind of raw format, Or you can go to xp123.com/YouTube. You'll find the old sessions time delayed by a week or so and lightly edited. Thanks for watching. Hope you can join us sometime. Bye-bye.